Hi everyone, this is Nilson Lima, and we are here to put in the community uh, uh, free ocean project. And this we have a fellow developer. It has a request. It is to make inside the water when we have a underwater process. It is to make a distortion and fog. So he'd like to have a bubble to represent the city, and he didn't like it to have the fog applied inside that dome inside water. He asked another fellow developer give him a solution. I have checked the post, and I am showing here how to add this effect in the underwater process. I have made a copy for this underwater process. It was M underwater PP. I added and cut, but it's exactly the same material, and I will show what I have done. And we have here I made a little island here with a sand. This sand was taken from the vehicle game from Epic. It is free. It is in the Learn tab, so you can grab this sand material from here. It like blend with this rock to simulate the cliffs, and you have some angle, so it's quite nice to use it as it is. And let's just, before diving into the material, I have made it like a ramp here so I can know which direction I need to go. So this is the bottom of the ocean. We have this post-processes. He calls this a distortion, and also far away you see a fog being applied, and right there when you can see that illuminated area, it is the dome. I have placed it there so you can like see it far away. I was discussing with Freddy, it is our fellow developer. It asked this, and you'd like to have less light inside the dome, and he was asking if you can apply another post processes, or I think you can just use the same material. So I am inside the dome, and there is no post process. As we can see that the palm is right here, it's not being distorted, but outside the dome everything else is fogged and distorted. Okay, so just to take a look again how it is when you leave, and I will show two things. One is first is the material for the dome. It is like this. You can see it is a sphere. You can see it is it's not even made. We are using the engine basic shape called the sphere. And this sphere, take a look at this. We have this location for this sphere. It is important to know it. And the scale, it means the shape by itself, if you open it, has a size of 100 by 100 by 100 in all directions. It means that multiplied by 50, the total units we have for scale is 5,000. Okay, then what we have to do now is to show the glass. This is the material for the glass. First, we mark it here as translucent, two-sided, just for us to have that little feeling of being some thickness. I have placed screen space reflections, so when I walking towards the glass I can see my reflection, because that was expected when you are walking to a glass, even inside water. You have to add here, it is important, surface translucency. You have to left here apply fogging and directional light. I remember I changed it to 2, but I really don't sure. You change this and see if it changes anything. The default value here is 1. Everything else is not touched. Everything is the same. So what this material does, so we use as base color basically white. We are exposing this as a parameter. Full metallic, yes, that's how we make glass being reflective. Zero roughness to guarantee that it is fully reflective, the surface. And for opacity, you have 2 choices that I have placed here in the material. You can have, if this is true, a fixed opacity, or you can have, using Fernandes, varying from min to max opacity through a lerp, clamping this, driving this opacity, because it really is, you can have at different angles and looking, you want to simulate different thickness along the glass, so it is nice if you can have this for now applied, and makes the also helps the glass to show under the water better. And we are using the same Fernandes here, so you have not changed any parameter in this Fernandes. Another lerp with a mean refraction and a max refraction. This max refractions is for use it in for 3D artists for crown glass. It is a scientific glass, I guess. And you fed here refraction. Nothing else. We don't have normals. We don't have specular, because we don't like specular here. It's just a simple glass. And from this material, I have, of course, an instance that I can tweak the values here. You see that I'm not using fixed opacity, so I have the mean opacity appearing here, just with max opacity. I have given some emissive, so you can tweak this as much or less, because this amount of emissive, it's important depending on the how dark and how much fog you have underwater. Otherwise you'll not be able to see the borders of the glass. So you can like change this for less until you feel comfortable with the amount of borders that have been shown here. Of course, we are not in that deep ocean. It could be even deeper. Okay, and if this was something that someone asked too, how can this fog here being changed? Inside the underwater material, you have fog density. I have already changed this value. You see it like 0.3. So everything now you look at, it's darker because of the depth. You see that when I have changed this for a higher value, it's less visible, the border for the glass. Okay, this hardness here is changed. I don't think we need to Okay, this is another thing. Sorry, you have to look at this. It's a parameter we have created in the material. Well, let me put this here. Now we will check the underwater material. So this is basically what it looks like. Of course I have changed this. It is the sphere mask used. I strongly suggest that unless you have a box or a sphere to mask like this, it is okay to use sphere mask or box mask. But then you might have a complex shape that you want to mask. Well, for this you need distance fields. So distance fields you have to enable in the project, and here you have the function distance. Where it's distance, something like distance to nearest surface. So what you want here is to know from a certain position in your world, you have this output here given in centimeters. So how much centimeters this position is from the nearest surface where the distance field is calculated. So every time you turn on the distance field, you will have like we have in our sphere here. See, once it is enabled, it will create some information and store inside your project, and it also consumes some memory. So you can tweak the value for the distance field to be more accurate, and this of course you will use even more memory. But for this little sphere, this is just the amount it is using. But it's not just for the sphere. Everything else is having this information being calculated. Being those cubes, being the landscape, it also has a distance field generated for it. Your pawn, your character, you also have for his skeletal mesh the distance field created. So you have to tweak this value in order to not consider different objects in your scene, not interfere with your calculations. Well, of course this is a harder material to create right now, so we're still doing with the sphere mask. So sphere mask, what it means here, I will explain the most of my English can give. What I have to create a sphere, a 3D sphere, okay. It will compare the current position you are with the position you want the sphere to be created, because depending on where you are, the size of this sphere will be different. Remember, this represents your position in the world, and this is the real sphere position. So if you check this parameter here, I call it position. The position is here. This is the instance, material instance. I have fed the RGB channels with these values. Where did I get these values here? I just went through this sphere and I copy the location. I got this location and I fed position. The fourth is ignored. So these two informations tell this node where to create the sphere. And instead of having all that trouble to look in and feeding the object with its known scale, I'm using this node here. It will give me automatically the max bound scale where this is, where the place I am. And when we are talking about in this position of that sphere. So this value here will return those 10. And the object scale, it is this. We have multiplied and we have our 5000 for the radius. Hardness tell the following. It means how accurate my mask is. Like if I use 1, it's really sharp, but you see the mask is perfect, but my sphere is not. Why? Because it doesn't have too many faces. So you can see here of the faces, and the problem is that it doesn't look good because the sphere is perfect, because it is pure mathematical, while the sphere itself is not. This mesh has faces, so what you have to do is taking the hardness, take it down a little bit until you feel now it is okay, right? Basically, this is the value you have. Now this sphere, you have it to invert it because you want to mask something, and you will feed it to an lerp. This lerp does not exist. And what do you put inside this lerp? This original here and the fog. And then this exit from this lerp, you feed the previous lerp that was already in the material. You feed again this one, because this is when you are outside the water. Okay, and in this lerp, it means for me this is the material I want to see while inside the bubble, inside the dome. And this alpha is using the stencil mask as it was, and you're feeding the emissive. And Freddy has asked how he can have while inside here, because he doesn't want to have all this intensity. It makes sense because you are inside water, so it should be darker. So you have two choices. Or you, knowing that you are inside this sphere, you can use the overlap event in your actor against the sphere, and you can drive the intensity for the sunlight. You can change this, so while you are here, this could be less. I'm not sure if skylight will give the same amount. Let's see, 0.1. No, skylight is not good enough here. It just like give you something good in the shadows, but not anything else. So you can do this, or you can like pick this. You can multiply with a scalar. This scalar will tell this inside DOM intensity. Let's call this, and as we are multiplying, 1 means you have exactly what we see now. Let's see if we can put like 0.7. Let's take a look. Let's see if you can. I took the wrong one. Side DOM intensity. If you have 1, see, 0.4, 0.3, 0.1. Maybe it's too much, but hey, it is still nice. I'm not sure how much. It will be nice to, given the amount of fog, if you could drive this one also, or feed them separately as I have done here. So I hope this has been useful, and take your time, Freddy, to study this and understand the things are done. And a good exercise for this would be, what if I have a second DOM? At the side. How would you now apply the same effect for a second DOM? There are many ways to do this. You want the easiest one, and this would be create a second instance for the underwater cut PP, and you fed the location. It is now different for this second sphere. You feed in the second instance in here. So now this is m underwater cut pp inst. It could be m underwater cut pp inst 2 for the second sphere, 3. And once you have this many instances, you want to blend them. How do you blend post-processing? You have to look, let me see, I guess it is in the BP underwater. BP underwater, let's see, blah blah blah. Oops, no, not here. Yeah, here. We are getting the post-process volume, and we are inserting the water lens, the wet lens, sorry. And this happens when we are out of water. See, we are underwater, add or update blendable. We are given the material here in saying the weight is 1. It means turn on this effect for this post-process material. And otherwise, it means for amount of time here, when I get out of water, the weight goes to 0, driven by this. Once this distortion value fades away and finish this timer, then the wetlands effect goes to 0. So this is one way. You use something similar. You blend several instances. Okay, Nilson, how are you do this? Oh, you have to make this procedural. So you can pick your, or you create a new blueprint, and in this blueprint you make an array with the several spheres you have, and then with this blueprint you have this amount of spheres. You can make a for loop and go each one. You can automatically inside the blueprint get this location and feed each instance of the material. So it's really easy if you try hard and get there. I hope everyone liked this. Make sure to take a look always in this Ocean project. As community, we are adding some features as soon as we can. I'm working with another feature that I need for this project, and of course I don't have time to do everything the community needs, but this is something that I could help. I'm glad to do it. I hope everyone can enjoy and use this. And remember, if you change this project for your own use and you think that your changes are good to share with the community, since this is a pretty amazing free project, again, it is free and it's quite nice. Share as we have shared this stuff with you. Thank you very much. Bye bye.